Using OpenStack's textbook, Calculus Volume 2, we are starting Section 3.2 on trigonometric integrals. So we're going to look at several different types of integrals involving trig functions and talk about different methods of finding their integrals. We're going to start off with examples that are products of sine and cosine. So here we have cosine to a power x times sine x dx. In this case, we're going to let u equal cosine x, and du in that case would be negative sine x dx. I do want to point out real quick something that a lot of people don't think about. When you see cosine to the third x, that's the same as cosine x parentheses to the third. The x isn't to the third, it's just the cosine, but you can write it both ways. So if I rewrote this as cosine x to the third times sine x dx, the sine needs a negative to be du, so negative 1, negative 1. Now we have the integral, negative 1 times the integral of u to the third times du. That would be negative 1 times u to the fourth over 4 plus c. And we replace our u, negative cosine to the fourth x over 4 plus c is the answer. Sometimes you might see it as negative 1/4 cosine to the fourth x plus c. Same answer. So in the next one, we're going to talk about integrating the cosine to a power x, sine to a power x dx when k, the power on sine, is odd. Okay? So if k, the power that's on sine, is odd. To do this one, we are going to use sine to the third x, rewritten, broken up as sine squared x times sine x. Okay? The reason we're doing this, sine was to an odd power, and we want an even power in there, like squared specifically when possible. So we have integral cosine squared x sine squared x sine x dx. We're going to use our trig identities to replace sine squared x with 1 minus cosine squared x. We're going to distribute cosine squared. Cosine squared x minus cosine to the fourth x times sine x dx. U is going to equal cosine x. Du would then be negative sine x dx. If we have a negative on our sine, so this is still times, by the way, then we need a negative out here. So we have negative 1 integral of u squared minus u to the fourth du equals. Now I want to point out, we don't like our higher power in the back, but the sign is a minus. So if we distributed the minus in there, the negative 1, we could write this as integral of u to the fourth minus u squared du. We're going to end up in the same place either way. U to the fifth over 5 minus u to the third over 3 plus c. Put your cosine back in. Cosine to the fifth x over 5, or 1/5 cosine to the fifth x, minus cosine to the third x over 3 plus c. Do not forget the plus c. Now, in example 310, we have an even power of sine. So in this case, with the even power of sine, we use a trigonometric identity that says sine squared x, and this is what's called, by the way, a power reducing formula. Sine squared x equals 1 minus cosine 2x over 2. Now we're going to rewrite it as 1/2 minus 1/2 cosine 2x. The reason I point this out is when the monomial is on the bottom like this, I can split this up into two pieces. I'm being very specific about that because later on we're going to look at problems where we take a fraction apart a different way. But if it's a monomial on the bottom, no plus or minus, I can put it under each of the numerator's parts. So we're going to rewrite as integral 1/2 minus 1/2 cosine 2x dx. So I'm going to probably go into a little more detail than the book does, just because we're still working on these whole integration things. 1/2 integral of dx minus 1/2 integral of cosine 2x dx. This one's easy. This is 1/2 x. However, here u equals 2x, du equals 2 dx. If I need a 2 with the dx, I need a 1/2 outside. So that's really 1/4. The integral of cosine is sine of u, which is 2x plus c. And there you have it.